we will be discussing autism and psychic powers, the ESP Enigma, with neuropsychiatrist and autism expert, Dr. Diane Hennacy. Learn about our rapidly evolving view of autism and what powers these individuals seem to possess. Do they indeed have mental telepathy and a sixth sense? Do they in fact have psychic abilities? What do we currently know? And what does the data support? Much more on this podcast episode. Welcome back, everyone. Here's my take on Dr. Diane Hennacy. She is the preeminent world expert on autism and extrasensory perception, or ESP. As an accomplished author, researcher, public speaker, and neuroscientist, Dr. Hennacy's experience in the field is impressive. Moreover, with a medical degree and training in medicine, neurology, and psychiatry at the Johns Hopkins University, her pedigree lends significant validity to her work. Her nationally acclaimed book, The ESP Enigma, covers in depth her research findings and hypotheses about the brain and psychic powers. This was an eye-opening interview. We are just beginning to understand the brains of autistic savants. They appear to have paranormal phenomena like telepathy and telekinesis that are not fully explained by scientific methods. Most importantly, their psychic abilities appear reproducible. So, the biggest question remains: do autistic individuals actually have superpowers? What do we currently understand about ESP, and what does the scientific evidence support? Listen up as we discuss autism and psychic powers, the ESP Enigma. Check it out. Hey, Diane, how are you?
Good.
Listen, thanks for joining us. I'm very excited to have you on the podcast today to talk about a field that we're learning so much about recently, and that's autism and the special powers that these individuals have, including potentially ESP. And that's a big focus of your research and the books that you've published and the podcast that you run. So look forward to hearing your expertise on that topic.
Yeah, thanks for having me.
I guess we'll start with just the basics for our listeners, but what is the definition of autism?
Well, autism is actually a syndrome, and it has three components to it. And so it's a developmental disorder in which there's something aberrant about the way that language develops. So it could develop early, as you see in children who have hyperlexia, such as Ramsey's, who started reading at 4 months. Or it could be the other extreme would be children that don't develop an ability to speak or express language at all. And it also is a social development disorder. So they have difficulty reading social situations, reading people's emotional reactions sometimes in the typical ways, and responding to them in the same ways. And then the third component is engaging in repetitive behaviors.
Now, what about the term spectrum, which is often used? How is autism different than Asperger's, and where are they on the spectrum?
I really actually don't like the use of spectrum as it applies to autism. I mean, when I think of something that's on a spectrum, I think of something that has a continuum. So, for example, something like intelligence or height, it's something where you can put people into a bell curve, based on standard distribution. Whereas with autism, we have individuals who have such variant expressions of those three components of the syndrome that they can really look very, very different from one another, and they don't have the same. Their brains are different from one another. They don't even have a common genetics that's been identified. So I think what's happened is that it's really a cluster of different conditions, one of which is a sensory processing disorder, that have been all been lumped in together in large part, I think, because a busy pediatrician needs to, when they see a child that's not developing normally, and it makes it easier for the pediatrician to just say, okay, this fits the criteria of autism, and to then send them on for the kinds of services that are available.
Now, how common is autism, and are there any known predisposing risk factors? For example, is it hereditary?
Well, so in the United States, the last numbers I saw were that there are 5 million children with autism, and about a quarter of them have the non-speaking variety of autism. So that's well over 1 million children within the United States alone. The incidence used to be 1 in 10,000 when I first started out in the late 80s, 1980s, and it's now 1 in 30 children. And what was the second part of your question?
Are there any risk factors? Are there any
Oh,
predisposing risk factors?
well, we've known for a long time that there are certain genetic conditions that predispose to autism. So, for example, one of them is Fragile X, and there's a very specific sort of facies, that somebody with that genetic condition has, and they have, for example, a high arched palate, and various other, physical anomalies. Um, so besides that type of genetics, then there's also, it does seem to run in families, but we really don't have a single gene identified with it. I mean, I think last time I looked, there were about 1,500 different genes that have been associated with it. Um, and then it appears that children who have a mitochondrial disorder are predisposed to it. And the mitochondria are the sort of the powerhouse of the cells. They're what give us energy, and the brain is packed full of them. And our mitochondria are very susceptible to environmental insult. And so we get all of our mitochondria essentially from the mother's egg. And so it could be that something's happened to the mitochondria in the mother, and then it gets passed down to the child. And then after that, if it was a female child with autism, then she's passing on her mitochondria. So you would anticipate that it'd be passed on to the next generation. And because women have a milder version of autism in general, and it's less frequent in women than it is in men, we don't really have that many cases yet in which we can really identify the genetics real tightly.
Now, at what age, because you mentioned the kids and the pediatrician and recognizing that there's issues in terms of interaction, at what age is autism typically diagnosed, and what specialized care do these children often receive?
Well, the typical age at which it's diagnosed is around 2 years old. It's basically there's an expectation that the parent has that the child is going to be able to express themselves at that age, and so it's when they start talking that they or not talking that the parent realizes that there's something wrong. And so I'd say that typically that the parent notices they could notice something's different as early as the first couple of months if the child doesn't develop a social smile. And so that can be one of the indicators. But otherwise, I'd say most parents don't realize that there's a problem until that they're expecting the child to be able to communicate with them. And then they realize that there's something aberrant about their communication style. It's at that point that they start expecting the child to interact and play with other children. They're seeing that they don't interact with other children the same way, or the child is more mobile and they can engage in these repetitive behaviors, and that they're noticing that as well. And so it's at that point. And then the statistics that the CDC gives us are the statistics for 8-year-olds, because they know that if you've got autism, it will have express itself by that age.
Now, tell us about your personal relationship with this topic and with this field. How did you first get interested in autism and the science behind it?
Well, my first introduction to it was actually when I was, in my late teens, early 20s, somewhere in there, when I read a book titled Dibs in Search of Self. And it was written by a psychologist who did play therapy with this boy who was having massive behavioral problems, and he was socially isolated, and his family was concerned about him. And after a year of play therapy, the child's behavior improved significantly, and the psychologist determined that he was actually a genius. He had an IQ of 168. And I come from a family in which there are a lot of very, very gifted individuals, and I've always been interested in genius. And so my first interest was, is this a population in which they're highly intelligent, and that is what is causing them to sort of have difficulty socially, because they're maybe have the mental age of a 10-year-old when they're 6, and they just can't relate to other children. So, and my mother was a special ed teacher. And so I was interested in that. And then it was in 1986 that I met Oliver Sacks after he had written his book, The Man Who Mistook His Wife for a Hat. And in that book, he tells the story of these two autistic twins who were institutionalized, who could just spontaneously generate multiple digit prime numbers. And they said they just perceived the information. It was that they literally saw it, and that they weren't calculating it or deriving it in any way. And they weren't even capable of doing simple math. And yet they could do that. They could do calendar calculation. For thousands of years, they could instantaneously tell you how many matches had spilled onto the floor. So I thought these children had their ability to process information is different from how we standardly think of how we process information. That we think of it as a more linear process rather than a gestalt process. And so I thought it was really important to understand it in order to really understand the brain, because ultimately my interest has been in not only helping people, and that's why I became a doctor, but also my undergraduate work was in neuroscience, and I really wanted to understand how does the brain work. What is the relationship between brain consciousness? And so I saw studying savant syndrome, which has been recognized by scientific and medical professionals as real. I saw that as kind of an important piece to trying to understand the greater picture.
Now, what do you think is the most common misconception in the public regarding autistic individuals?
Oh boy, there's so many misconceptions. So I mean, it's I'd say the most common misconception is that they are mentally retarded, and autism is totally independent of IQ. You can have people that are very low functioning, low IQ, and you can have people that are genius IQ. And so much of how we judge IQ is based on how you do on standardized tests. And if you struggle with being able to use your body to even take the tests, or you think differently, you're not going to score very well on those standardized tests. And yet we those of us who have studied the cognitive sciences know that IQ tests are imperfect, that they only really are good for giving us an idea, predictability within sort of our educational system, but that if we're looking at cognitive abilities, it goes way beyond that.
And in terms of why is it so important? I mean, you're talking about there's so many public misconceptions. Why is it so important that we raise awareness and educate the public on what autism really is and what these individuals truly experience?
Well, I think it's important for several reasons. I mean, the first point is really, I think it's an issue of a humane approach to individuals that are under our charge to take care of. Whether we're the parents or the clinicians or the teachers working with them, that we need to have an understanding of who they are, what they're capable of, so that we can meet their needs, rather than just relegating them to the dustbin and just saying, the situation is hopeless. So I'm a big advocate for accommodating them, just like we accommodate people that are blind or deaf. But then, the bigger picture is really that I also think that they're teaching us something about human capacity, and that if we don't explore what they're teaching us, then we're also have a more incomplete sense of who we are and what the human is capable of.
Now let's get into the real center of your research and what is an incredibly fascinating topic, I think, for the majority of public when they hear it. But ESP, extrasensory perception, and what exactly is ESP, and how accepted is this phenomena in the academic community?
Well, ESP, which stands for extrasensory perception, is the study of phenomena like precognition, knowing things before they happen, or clairvoyance, seeing things that are not in within your physical, your immediate physical surroundings. Telepathy, being able to access somebody else's thoughts. Psychokinesis, which is the ability to manipulate matter through your thoughts. Those are all aspects of ESP that are really looked down upon with great disdain by the scientific and medical establishment. Yet at the same time, what's always been interesting to me is that if you, behind closed doors, privately talk with a lot of individuals, they'll say, I know you're onto something. I just can't be public and admit that. I've had my own experience. I've had people who are surgeons tell me about experiences that they've had in the operating room with people that have had near death experiences and they just say that this thing happened that I can't explain, or they may have had their own personal experience outside of their professional life, but. So I think it's one of those taboo areas that people don't want to jeopardize their reputation and their career over, but privately, a lot of people are interested in whether or not it can really be approached with scientific rigor.
Now, your research suggests that children with autism may have certain ESP powers, and can you give us some examples of these abilities that you've identified?
Um, well, so first of all, I mean, I think that what we think of as savant syndrome is so similar to what we think of as ESP that I really think that I think it'd be better to just look at all of this as there's savant skills that that a lot of these individuals have. And because if you think about it, being able to access prime numbers that are in the 12 digits, 20 digits, when there's no good algorithm for it, and you say it's just pure perception, to me that is as remarkable as, if not more remarkable than some of the for example, like the remote viewing research that was funded by military intelligence, where you had these people who were assets of the government who were able to locate hidden nuclear facilities or whatever. So so that's the way that I look at that. And in terms of my own research, I started out looking at savant skills, looking at these children who seem to know how to do math without ever studying math, or language without studying language. And those are things that are reported definitely within the population I've been studying. And I've been able to test that, with some individuals, for example, Ramses, who could read 8 different languages when, before he was in kindergarten. And these were disparate. I mean, these were languages as different as Japanese and Russian and Hebrew and Arabic. And But when I was in the course of my studying savant syndrome, the parents were increasing and teachers were increasingly telling me, "Oh, by the way, these children are also telepathic." And I thought, well, if I'm trying to test them for the meaning of a foreign word, foreign language word, and I know the answer, and that's how I'm testing them, then telepathy would be a confounding variable. So then I started looking into, are they, do they have ability to read minds? And I've had people from all over the world contact me over the last 13 years reporting that their child can do that. Um, and I've been able to test some children who can type independently. So a lot of the experimental footage that people have seen behind Kai Dickens' paywall is the experimental footage that she took, which is of the children using the stencil boards. But I've seen children who are able to write it independently or type it into an iPad or into a computer. It's just that they don't want to be part of a documentary. They don't want to be filmed for that, and so it's that's why the public's not seeing that. But I have seen it, um, and it's remarkable that they're able to do that. I haven't been able to get the amount of separation that I would like. I mean, I would, ideally I would have them, um, miles away, or and the person reading their mind, in a separate location. But um, it's hard to separate these children from somebody. In many ways, there's this kind of dependency that they have on their caregiver, and they really they don't want to be separated. Um, some of these children have had dreams and or visions in which they have a very clear um, that they have a very clear description of something that's going to happen, and then it happens. So one example of that is this girl um, whose parent, is interviewed in the podcast, who had this dream that her father slipped on ice and broke his leg, his hip, and they live in Arizona, and there's, and so it just seemed like kind of a wild, you know, a wild dream. And then, within a month, he was on a business trip and he slipped on the ice and ended up in the hospital with a broken hip. There was an example of a child who had that kind of experience that was reported by Bernie Rimlin, who was a psychologist and autism expert and father of an autistic child who created a center in San Diego. And he reported this child having this dream of her father dying of a heart attack at the dinner table, and that happened the next day. And
Mm.
the way he reported it was that the child didn't have the same emotional reaction that you would anticipate because she already knew it was going to happen. So those are the kinds of reports that are there have been. But it's hard to experimentally test precognition because it's never known what the time frame is. Is this going to happen an hour from now? Is this going to happen next month? Is it going to happen 5 years from now? I mean, once you're getting outside of locality of time and into this non-locality, then time is really kind of a meaningless concept. Um, so and then some of these other things I haven't really tested. I've been focused on trying to demonstrate the mind reading, is that, because that's something that you can, if you get the conditions right, you can demonstrate that in real time, and there are things that you can do to try to figure out exactly what's going on, from a mechanistic standpoint.
Now, there's some evidence that these autistic individuals can be hypersensitive to stimuli, for example, colors, vibrations, weather patterns. How is this different than potentially ESP?
Um, I don't know that it is different, and what I mean by that is, there's the telepathy that's been reported by people like Dean Radin, at the Institute of Noetic Sciences, and other other parapsychologists, in which you have people in Faraday cages, and you see that a statistically significant, deviating from chance ability to have information transmitted, but it's never 100%. I mean, they're happy if they could even get 30%. And so that's never been enough to move the needle in science. And one of the things about these autistic children is that especially the non-speakers, is that they 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 can give you random numbers or random words, with 100% accuracy, and they can do it, reasonably easily. Once they settle down, I mean, they can get, super, they can get hyper, stimulated. And, I've thought about, what's the mechanism going on here, and my opinion is that it's either that they're in some kind of synchrony with the individual, in which case we would anticipate that their brain waves would fall into synchronization. You'd be able to see something happening instantaneously in the one individual and happening with the other. And so I've paired up with a group of scientists at the University of Arizona, and we're getting far more expensive, QEEG equipment than I've been able to work with in the past, because you need that, and you need a higher level of equipment to kind of look for that synchronization, to see the signal and the noise, than what you have if you're just clinician using the EEG. It's just a very different technology that you need in order to demonstrate that. So that's research that's yet to happen. But if I don't see that synchronization, then another hypothesis is that this is really, rather than it being ESP, extrasensory perception, that it's more what I would call HSP, heightened sensory perception. So, in other words, this ability to read vibration, to be able to pick up the information in a way that really just shows that they've got, for example, a hearing ability that where they can hear things that are inaudible to the rest of us, but they can hear it. And we know that when people read silently to themselves, there are some inaudible subvocalizations. I mean, that the vocal cords do vibrate. And so if they're able to pick up any kind of sound from that, with their exquisite hearing ability, then that could explain why they're able to get this 100% accuracy. And if that's the case, then you would expect that to drop off with distance from the individual that they're doing it with, as opposed to the sort of ESP hypothesis, in which distance is irrelevant. And so that's the kind of research that I want to do, so that I can kind of distinguish between the two.
Super interesting. I want to go over some of the autistic superpowers that have been identified, named, researched, and you just give me one kind of mind-blowing example. But for example, hyperfocus, intense concentration on a certain task. Give us a mind-blowing example of that in a patient that you've seen.
When you say hyper focus, I mean, so can you explain to me kind of what you're thinking? Because I think you're thinking of something already. So
the ability to focus on a task and not get deterred or get pulled away like we all do when we're multitasking. Just the ability to focus on a topic 100% and not be subject to distractions.
boy, I don't know that describes these kids. They're highly distractible. Yet at the same time, they have, an ability to just grab onto information in a way that we can't, like they can, so for example, it's hard for them to be fooled. Some of these, hard for them to be fooled by optical illusions. They can just look at it and they already, they see it differently than we do, or embedded figures that they just can take it apart. Where because it's perceptual for them. It's not derived. But no, I would not describe them as hyper focused at all. A lot of them also have ADD, and which is and ADD, for your audience, is attention deficit disorder is actually a concentration disorder, and it's usually related to low functioning in the frontal lobes. And so that you get distracted easily unless something just really engages you, and so so the kinds of things that engage people with ADD are things that kind of give them an adrenaline rush, oftentimes. And a lot of these kids with autism have obsessive compulsive disorder, and that's another concentration issue. But the difference with that is that with obsessive compulsive disorder, it's that they can become hyper focused in a way where it's hard to redirect their attention. So once again, they don't have they don't have control over their ability to whether they're concentrating on something or not, and so it ends up being another thing in which they can be heavily distracted. It may be that you're trying to get them to do a certain task, and there's something else that grabs their attention, and they're focusing on that, and you can't get their attention back to what it is they're supposed to be focused on. But in terms of hyper focus being involved in these savant skills, I guess you could say that when they're doing this, like these mind reading tests, they're very focused on it, for short spurts. It demands that.
Now, give us your crystal ball view. You had said that we're really just starting to understand the minds of autistic individuals, and there's so many misconceptions in the public, and we need to raise awareness. But give us your crystal ball view. What major breakthroughs do you believe are going to occur in our understanding of autism in the next 10 years?
Well, first of all, I think that we're going to find out that a lot of these individuals have a really high intellectual capacity. And that's something that I'm hoping to be able to demonstrate once again through doing the EEGs studies. That we can really basically identify what the source is of their communication problem, and find a better workaround for it than what's happening now. I mean, what's happening now is these children are being put into applied behavioral analysis, which treats them as though they're stuck at the language development of a small child, and a lot of them, there's nothing wrong with their ability to understand language. It's the expression of language that's problematic. And as being a neurosurgeon, that there's a profound difference between these different types of aphasias or disorders in language. And so I think that we'll be able to legitimize, their ability to understand language, and that we're then going to have to find ways to accommodate them. Like, Stephen Hawking had, a way of accommodating him, but he was given the benefit of the doubt that he had this great mind because he'd already demonstrated it before his ALS, kicked in. And so I think that's one breakthrough. I think that we're also going to see that our concept of consciousness in the brain is really incorrect. I mean, I think that what savant syndrome is showing us is that our brains are really more navigational devices for navigating consciousness as more of an informational field. And so I think that that's going to be a breakthrough in understanding them that also applies to the rest of us.
Well, listen, what a terrific interview, Diane. I think that the real take-home point for our listeners are that we are just scratching the surface of what these autistic individuals are capable of. And I couldn't agree more with you. I think that the general public views these individuals as slow, and in many situations, it's quite the opposite. They're different, but they're certainly not slow. And I think that interviews like this and the podcast that you do and the research that you do help raise awareness, and they help change the public perception. And that's really what we should be focused on. And like you said, what the science and the early evidence is showing is that not only are they not slow, but they can be superior to non-autistic individuals in many different types of scenarios. And I think we're just starting to understand that. And I think by learning what's going on in the autistic brain, we're then going to translate that into what's going on into the non-autistic brain, and we're going to learn a lot more.
Correct. Yeah.
Well, listen, I appreciate your time. Thank you so much, and have a wonderful weekend.
Thank you. You too. Bye.